school for everything for you. So just leave the door open.
Arigato.
Okay. Okay, second unit. So, first unit, hopefully you can kind of see why I'm progressing things the way we are.
Which room?
The middle school printer. In the open area up there. Head that way, look for the printer. So, first unit, all about numbers. I've really been harping on our first metaphor of the Jenga tower. I need you to know how to add, subtract, multiply, and divide. Because really, if you don't have those 4 bases of math, the whole tower falls down, right? Today we're going to start working on algebra, which you should have some experience with. The big difference between algebra and just basic numbers is now we put in more letters. Right? And granted, I've been putting some letters into certain equations I've been working with, but more and more as you progress into math, rather than asking what 6 plus 7 is, I say, well, what about x plus y? What if x was 4? What if x was y was 2? What if it was 3 and 7? Like, you know what I mean? Like we can change it up. So therefore, today's topic is on variables. So we're just going to start right at the very, very beginning with how do we change from working with numbers to letters. So starting with my review page here. Hopefully you know how to add, subtract, multiply, and divide. And hopefully these terms are familiar to you. Let's just review them. What makes something a natural number? It's like a whole number, right? 2, 3, 4, 5. Yeah, it's like a whole number, right? Integers throws on those negatives, though. So, can you handle 5 minus 2? Can you handle some double negatives? Rationals is kind of an overarching term for things that you can write as a fraction. 1.3 repeating would also count. 4 over 3 is the same thing. Irrationals is kind of what we work with a bit, then well, what if it's a square root? Can you handle that? Our goal now, though, is to take that and start adding on variables. So here's the 2 main scenarios in which we use variables. The first one is we have a formula. For those of you who eventually take chemistry and physics with me, we use variables all the time. I found a slide here that has a bunch of formulas, like say E equals mc squared. I don't know what the mass is yet, but one day I'll find mass, I'll plug in that value. I may not know what C is yet, but one day when I find C, I'll plug in that number. Right? I mean, I wouldn't expect you guys to recognize these formulas, but I mean, you guys have worked with formulas before, right? What about like area equals length times width? You've done that one, right? Or circumference equals 2 pi r. Area equals pi r squared. Often we use variables and formulas because we don't know what those numbers are yet. One day we will. The other main way we use variables though is with algebra, where we're going to solve backwards for an unknown value. Okay. Because today's kind of a shorter day and it's kind of an intro, we're actually not going to get into the algebra section just yet. But most of you guys probably know how to solve this, right? 2x equals 4. You guys know how to solve that? What do you do? Yeah. Essentially dividing both sides by 2. Right? That's algebra. We'll get to that. We're just building little by little. So, but those are the 2 main scenarios we use variables in. So, today I'm really focusing on the terminology. I want to make sure that when we're talking about something, we're all on the same page. So here's a set of bolded words that I have been really harping on all year so far. Like terms. Okay. We have to know which things can combine. Let's do some examples here. 1 plus 2. Can you actually combine those? Is that valid? They're both whole numbers, right? 1 plus 2 is 3. That's valid. Those are like terms. 2x and 3x, are they like terms? Absolutely. They're both versions of x. You guys, give me your attention. So you get 5x. Can you do 3 minus 4? Sure. I don't know what x happens to be, but 3 minus 4 is -1. Those are considered like terms. You can add them together. What about x and y? Can you actually add them together? Not currently. If I knew what x and y were at some point, sure, I could combine them, but at this point right now, they're not considered similar to each other. Same thing here with x plus 1. I cannot add them unless I somehow figure out what x is. If I told you x was 2, yeah, then you can put them together. Same thing here. These guys are not like terms. So here's another definition that maybe you've heard before. If you have expressions with unlike terms, we call them polynomials. You guys heard that word polynomial before? It's not a new word too. Is this right here considered a polynomial? Poly means more than, right? Like more than a couple. Guys, it's like the third time. Shush. Okay, you can talk later. Although you might say, look, there's more than one thing here, we're going to put them together because they're like terms. So it's really not fair to call this a polynomial. Same thing here. These guys being like terms, since they combine together, you only get one thing. That's not really a poly of something. Does that make sense? But here, x plus y plus 2, since none of those things can go together, hence the term more than one, polynomial, more than one number type. Does that make sense? You've heard this before? So, here are a whole bunch of terms then. I've underlined the word term. These are things that can't go together. Come on. Like say 3x. Can this 3x combine with this 5xy? No, they're not like terms, right? This negative 7xyz, now there's a z on it. What about these ones right here though? Would these be able to go together? No, I didn't actually put a sign between them, but hypothetically if there was a sign between them, you would say you have 6x squared, right? If we were at, I didn't actually put a sign. Let's talk real quick though about what each of these things mean. What does 3x really refer to? Like if I break it down to its base level. Nice, that's what it would mean. 3x means x plus x. Plus x, it means you have 3 x's being added to each other. What does 5xy mean? It means x times y plus another 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 x times y. Because we don't really talk about variables in this way after a certain point. We kind of skip that. But sometimes I think it's worthwhile to go back to the very basics of like grade, I don't know, 5, 6, whenever you learn this, and talk about what these things really mean. The 5 means you have 5 of them being added together. And the x and y, though, are kind of being multiplied by each other. What if I had negative 7xyz? We can clearly deal with negative numbers, right? I've been working on that over the last little while. Well, okay, let's try this. What if you had an x times y times z, and you added another x times y times z? That's not going to work, is it? What if they're all negative? What if you had a negative x, y, z? Maybe you can see where I'm going here. And you subtracted another x, y, z. How many times would you have to do that, though? Yeah. Now, it's not to the power of 7. That's different, right? But it means we'd have to subtract them. I'll just do dot, 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 and say do this 7 times. That's what that refers to. What about x squared? We were focusing on this a little bit last minute. When you square a number, it doesn't mean it's x plus x. It's x times x. The exponent does not mean add. The exponent means how many times it gets multiplied by each other. Does this and this have the ability to go together then? The answer is no. This means x plus x plus x. This means x times x. That's kind of different, isn't it? They wouldn't be considered like terms. What about 5x squared then? What does it really mean if you break it down?
X times x plus x.
And do that 5 times. Yes. Why can I add the 5x and the x squared? Why can they go together? Yeah, because they're like terms. Right? I mean, the like terms is the x squared, but maybe here's one way of looking at it. I'm just going to write it up here. This meant x times x. This meant x times x, plus x times x, plus x times x, etc., right? Well, doesn't this plus sign here just kind of continue the list? Isn't this a thing, that a thing, that a thing, that a thing? We kind of broke them up into one group over here, but doesn't this plus sign just kind of continue the list? Okay, so it's just continuing the list, that's all. But if I were to ask you to do x to the 3 plus 5x squared, Well, that doesn't really work because now you've got xxx plus xx plus xx plus xx. Well, now this one's got 3, that one's got 2, then they can't go together. So you probably haven't thought like this in math for quite a while, right? Like we don't rediscuss this, but I want to make sure it's really clear as to what the 3 in front refers to versus the 2 exponent. Because there's a very big distinction. Do I have the same slide in there twice in a row?
Yeah.
Oh, that's strange. My bad. Okay. Skip the second version of it, that's weird. So let's do some simplifying. Let's see if we can figure out what sort of like terms can go together. Again, this may be breaking it down to like levels that you're well beyond, but let's build those fundamentals. I see right here there's a couple of W's. Right? Those are like terms. You have 3W, and you have to add 4W, so you have 7W. Let me pick another color. Here I have minus 4x, and then I have minus 3x. So again, you got to be good at your integers. You're minus 4 in the whole, and then you minus 3 more. You're at minus 7x. Okay. You're at minus 3, minus 4 more. You're going further in debt, right? And then for the y's, you have 7 of them. You need to add 8 more. Okay. Does it matter which order they go in? It does not. Okay. In a slide or two, I'm going to talk about something called standard form. Sometimes we have a general way we go about writing something, but rarely the order does not matter. Let's try the next one. Which things on here are like terms? I'll just use colors to separate them. Here's an M. It can go with that M right there, right? So this M needs to add to 3 more, so we have 4, right? Okay, our M squared, so we have minus 3 of them. We need to add 4 more. Running tally means we're at 1 M squared. And then adding 6 more means we should be up to 7 of them. Then for our numbers, we have minus 2, minusing 5 more. How's that so far? Is that something you guys can handle? Okay, the next one I've done very purposefully. There are brackets with a negative sign. And you may have been shown different ways of solving this. One method that you may have learned is when you have a negative sign here, you flip all the signs, so you make it negative x, positive y, negative z. Anyone ever been shown to do something like that? Depends on what you've been shown. I'm going to show you what I prefer for how to deal with a negative like that. What we have to do is take 3x and subtract x. 3x subtract x. 2x, yeah. And then we've got 4y. We need to subtract a negative y. See how I'm doing this here? 4y subtract a negative y. A double subtract means to add, so 4 plus 1 gives us 5y. And then we've got 5z subtract 1z. 5 minus 1 would be 4. By the way, I always write my z with a little bar through the middle. I don't know what you guys do, but I do that so I don't think it's number 2. That's the worst mistake you can make, making a z2.
I saw that and I started doing that because my 2s look like these 2.
Yeah. So far, so good? This is pretty straightforward. Okay. Have you guys heard these words before? Monomials, binomials, trinomials, polynomials. I mean, monomials basically have 1 term. Binomials have 2 terms. Trinomials have 3 terms. Polynomials is just an overall expression referring to something that has multiple terms. That's all. Let's talk about some more words then. This is the first question. How you're asking about the first question on the assignment? So what I need you guys to know is just the words we use to describe terms in a polynomial. Here's the main ones. The terms are coefficients, variables, exponents, and constants. Okay. And sometimes we'll use the word degree. So here's an expression. Where are the coefficients? I would say that this and this is a coefficient. A number in front of a variable is known as a coefficient. Okay. If you have 1x squared, the coefficient is 1. 2x squared, the coefficient is 2. Have you guys heard the word constants before? Okay. Constants basically have no letter afterwards. Right? There is no x or y or z. If it's just a number, sometimes I'll say that. A number is a constant. It's close to all those other numbers, right? The exponent then would be whatever power there happens to be. What's the power of this term right here? 1. Good, yeah, because there's 1y right there. Does anybody know what the power of this term is? It is, yeah. And here's why. I don't know what the variable would be. Let's just make up a variable. Let's make it x. But if I made it x to the 0, isn't anything to the power of 0 equal to 1? So whatever this would happen to be, I don't care what it is, x or smiley face or y or whatever, right? If it was to the 0, it makes this whole thing 1. 7 times 1 is 7. So just so you're aware, constant terms have an exponent. The exponent is 0. The degree then is the highest variable. So for this one here, the degree would be 2, because 2 is the biggest exponent. You guys have done this terminology before? Awesome. Cool. Okay. So another thing you may have heard is something called a standard form. Standard form it's not like you have to do it this way, but it's a general consensus about how to make our math look easier to read. So the general rules are always combine like terms. For sure do that. And secondly, make sure that the exponent always is getting smaller. So put your x to the 5s before your x to the 4s, before your x to the 3s, before your x to the 2s. Does it have to be written this way? Not always. Right? I mean, unless I ask you to write it in standard form. So like this one here, is this good? Yeah, x to the 8, x to the 2, x to the 1. This is really x to the 0. Descending, right? This one's not considered standard form because we put the 2 before the 8. This one's not considered standard form because it goes 8, 2, 2, 1, 0, but these guys right here should have got combined. Straightforward. Awesome, moving on. Okay, so let's talk about a few examples to make sure you got it. Tell me whether these are monomials, binomials, or trinomials. Speak slower. So monomials, binomials, or trinomials. Tell me the degree, state the constant term. So let's do 1 at a time. 5x to the 3. Monomial, binomial, trinomial. Monomial. There's one thing, right? Degree. Is that large? It's 3. Why is the degree 3? That's the biggest exponent I have. 3. Is there a constant term? 0. It's sneaky, yeah. You could have written plus 0, right? There are 0 numbers sitting there. We didn't even bother to write any of them. So you can actually say the constant term is 0. So there is always a constant term. Even if it does not appear that there is a constant term, there always is one. It just might be 0. That's all. Let's try the next one. Monomial, binomial, or trinomial? Because there's 3 of them, right? Can any of them go together? No, they're not like terms, so trinomial. The degree is the biggest exponent, 7. What about the constant term for this one? Now, for different reasons, though, right? This 7 was the degree of 7. This 7 right here is what the constant term was. If it had been a minus 7, it would be a minus 7. Okay. Good? Awesome. So, let's try this one then. What if I tell you what some of the variables happen to be? Right? So this is kind of like when I was suggesting about with algebra. What happens if we know what some of the numbers are? Can we actually plug them in and solve? Let's try this task. It's 3 times x, but I now know what x is equal to. X is equal to 3.
Please excuse the interruption. Jacoby Provost, please come to the office. Jacoby, please come to the office.
It's 4 times y, but now we know what y is. Y is minus 1, right? 2 times w. We know what w is. W is 2. Did you guys solve that? You can handle that? That's 9. It's minus 4. That's 4. Why, it's 9. you handle it if I make it more challenging? 2, x is 3, y is minus 1. 3, w is 2, x is 3. 2 times 3 would be 6. Make it negative 6 with negative 1, right? 3 times 2 is 6. Times that by 3 would be 18. Minus 6 and 18. Go. Okay, the next one becomes just a little bit more challenging. 2. X was 3, but I have to square the 3. 4 times in by negative 1. Y is negative 1, I'll square it. And W is 2, I'll square it. It's a little more challenging. You've probably done something like this before, though, I'm thinking, right? We can do this in our heads. Okay, 3 squared, I'll start there. Do exponents first. 3 squared is 9, right? 9 times this by 2, or 18. With a negative 1, it'll make this a little bit minus 18. Does that work? What's negative 1 squared? Positive 1. Negative 1 times another negative 1 is positive 1. But there's still another minus sign sitting up front. So it's like subtract 1. It's like subtract plus 1 in a way. And then 2 squared is 4, right? So that's 4. 18 minus 1 more would be minus 19. Minus 4 more, minus 23. This is a so much smaller class than I'm used to. It's quiet. Am I doing okay? You guys comfortable with this? Yeah. Please make sure you tell me to slow down if I do this, okay? Especially now that there's way fewer of us we can. Okay, here's our last thing then. This is what we're going to lead into tomorrow. There's another notation that we can use, and this one you may not be as familiar with. It's the P bracket X notation. Have you guys ever seen this before?
No.
Okay, so we're finally at the new spot. Okay. Everything up to this was more or less reviewed? Okay, so we're built up. Here's the new block we're putting on top. Rather than write just an expression as 5x squared plus 7x minus 1, we might write it like this. P bracket X equals 5x squared plus 7x minus 1. You might say, Chris, why bother? How does it help? Okay. I'll get to that in a second, but do you guys agree the only real difference is there's now an equal sign, and there's this little thing on the left-hand side? Here's what this means. The P means it's a polynomial. We do that. The bracket X just tells us what variable we're using. Since we're using x's, we put x in brackets. Let me try something different here. Let's say the equation was 5y squared plus 7y minus 1. Well, then we would say this is a polynomial using y's. That makes sense? I don't know why you do this, but let's say it was 5 smiley face squared plus 7 smiley face minus 1. Does it matter what letter I use? Really? Actually, no. The answer is no. So you just say this is still a polynomial, and the letter that we're using is now a smiley face, not a x. That's all. So is that pretty straightforward, though? Okay, now for the question, Chris. Why? How is this helpful? Okay. There's actually a couple of different places it's helpful, but here would be the example. Rather than telling you what x happens to be and kind of having to write it out and say, let's let x be 2 or p be 5. You know how we did that a few slides ago where I told you what everything was equal to? Well, this notation is a shorter way of doing that. What I'm now going to do is I'm going to say p2. Well, you can even see how this is going to work. All this means is everywhere you used to have an x, write a 2. That's it. That makes sense? So you can even just see how I've done this example here. If I tell you p bracket 2 for this stuff here, everywhere you have a 2, plug in a 2. It used to be x. What's that? Yeah, I know, the bell's going any minute here. We have to up to 10. We're almost done, right? This is like our second last slide or so. You guys see how this is working here? Right? Essentially, wherever you had an X, just put a 2 in, right? So this is a bit of a shorthand notation to let us know what, like what value we want to plug in. If I then asked you for P of 3, all you do is go 5 times 3 squared plus 7 times 3 minus 1. That's all. It's a short way of letting us know what number we're going to plug in. That's all. Okay, let's do one last example, then we'll call it a day. So if I give you this expression here, don't get intimidated and throw your pen. Don't throw your pen, it's not that scary. The P refers to the fact that it's a polynomial. The X refers to the fact that X is our letter. Well, if I ask you for P bracket 2, it just means make all your X's 2. So 3 times 2 squared plus 2 times 2 plus 5. This means 3 times 4 squared plus 2 times 4 plus 5. 3 times minus 1 squared plus 2 times minus 1 plus 5. I'll let you guys handle the math line. But doesn't that make sense? So, this is where we're going to start next day. We're going to talk a little about how this notation can be used to help us with our algebra. Okay. Tomorrow we'll actually start with some more of our algebra skills, where we like divide both sides by 2, add 3 to both sides, that sort of stuff. Today I just really wanted to make sure we were all on the same page with our vocabulary. So keywords. Do you know what a constant term is? Do you know what you don't? Or is that just a facetious question?
I feel like I'm like everyone's on a boat and I'm trying to climb on.
Okay, well we can talk. The constant term is the one that has no letters attached to it. Okay. So like in this example here, the 5 at the end, see how the 5 doesn't have a letter next to it? That's a constant term. I need you guys to know what a degree is. I need you to know what a coefficient is. I need you to know monomials, binomials, trinomials. I need you to know how like terms work, that sort of stuff. Because if we don't have a good grasp of that naming stuff, then it makes it a little more challenging tomorrow when we review our algebra steps. Okay? So, questions, comments, concerns, conundrums, curiosities, complaints, criticisms, critiques, queries. I'm running out of words to throw. Okay. You guys good?
I'm gonna have 3 blocks classes that I'm really
Yeah. Yeah, come find me in about half an hour.
Alright.
Okay, so quick reminder then, guys. The assignment is actually not due until next week, Thursday, so you have a while. If you do want to finish some late stuff, tell me that I'm expecting it. You've got until the end of the week, basically. Other than that, we're kind of starting a new unit, so sound good?
I'm finishing yours, but
Okay, sounds good.